So this is 4-2, Chapter 4, Lesson 2, Compare and Order Rational Numbers. In this lesson, we are going to compare and order rational numbers. And this is part of our big essential question in this chapter. What happens when you add, subtract, and multiply, add, subtract, multiply, and divide fractions? The vocabulary we're going to be talking about today will be a rational number. What is a rational number? What is a common denominator and what is a least common denominator? So let's start. Okay. Definition of a rational number. A rational number is a number that can be expressed as a ratio of two integers written as a fraction. So that's a definition of a rational number. So basically what it's saying is that if you can write a number as a fraction, okay, in the form of a over b, because a over b is a fraction, then it is considered to be a rational number, provided also that your uh, denominator, which is b, is not equal to 0. So b should not be equal to 0, okay? And you can write it as a fraction. In 6th grade, you learned about a Venn diagram. And in this Venn diagram, uh, we are going to compare the classification of numbers. Okay, so we have rational numbers, integers, and whole numbers. Now, if you study our Venn diagram, okay, whole numbers is the smallest uh, uh, sphere here. So the set of whole numbers is included in the set of integers, and the set of integers is included in the set of rational numbers. Basically, what I'm saying is that if it's a whole number, it is also an integer. It is also a rational number. Okay, so whole numbers are integers and they're also rational numbers. Okay, integers are also rational numbers, but not necessarily whole numbers. Okay, what does that mean? Let's take a look at this example right here. The Venn diagram below shows that the number 2 can be called many things. It is a whole number because it is inside the set of whole numbers. It is also an integer because it is inside the set of integers. And it is also a rational number because it is also included in the set of rational numbers. Okay? The number negative 1.4444 is only considered to be a rational number because it is only inside the set of rational numbers. Now, what do you notice about integers? Remember when we learned about integers and adding and subtracting integers, we know that integers are definition of integers are whole numbers and their opposites. So if you get a whole number and its opposite, it is an integer. So negative 3 is an integer, 2 is also an integer. So those are integers. Okay? Anything inside this set is a set of rational numbers. Now look at 1/2. 1/2 is not a whole number because this is only part of a whole. 20% is also part of a whole. And if you notice, negative 1.4444 is also part of a whole. So when you have a decimal such as this one, which is not one whole, okay, you can already put it in the set of rational numbers. And that's the reason why if you look at our number bank, okay, and we look at, let's say, uh, 0.8, since 0.8 is not a whole number, it is only part of a whole, we can write 0.8 in the set of rational numbers. Okay, same thing with 2.2, bar notation on 2. So we know that 0.2 is also part of a whole, bar notation, so therefore it is also a rational number. On the other hand, okay, if you look at, okay, negative 1, negative 1 is an opposite of a whole number, but it is not a whole number, it's just the opposite of 1, so negative 1 is considered to be an integer. Okay, and the opposite of negative 1 is 1, and we know that 1 is a whole number, therefore 1 is a whole number, it is an integer. Okay, so 1 is a whole number, an integer, and a rational number. -1 is an integer and a rational number only. And finally, 1 and 2/3. Okay, you have a whole number and part of a whole in 2/3. So 1 and 2/3 is considered to be a rational number. Okay, just to put things in perspective. So when you have rational numbers, there is a thing called an irrational number. Okay, so in this case, okay, not all numbers are considered to be rational numbers. The Greek letter pi, okay, right here, represents the non-terminating and non-repeating number whose first few digits are 3.14. So when you talk about pi, pi is called an irrational number because it does not terminate, it's non-repeating, non-terminating, and it does not repeat, non-repeating. In 4-1, you learn that um, when it terminates and when it repeats, you can still make it into a fraction. So therefore, in 4-1, what we're talking about are the set of rational numbers. Okay? So when you have a number that does not terminate or does not repeat, okay, that is considered to be an irrational number. Okay? Now go online and answer the question below. Okay? The answer to the question will be prompted on the question that will follow this. Okay, let's move on. Comparing rational numbers. So again, when you compare rational numbers, again, rational numbers are numbers that can be put into a fraction, such as this one, a over b. Okay? But before we start comparing rational numbers, we need to understand that a common denominator, let me take this out first. Okay, we need to understand two terms, common denominator and least common denominator. Okay, so common denominator is a common multiple of denominators. So again, we are talking about the word multiple and denominators. Those words we need to know. After we know a multiple in denominators, then we will find out what the least common denominator is, or what we call in math as our LCD. Okay, and our LCD is the same as our LCM, or the least common multiple of denominators. So basically what I'm saying is that LCD is the same as your LCM. So if you find your least common multiple, okay, you can also find the least common denominator if you're talking about a fraction. Okay, and in this case, once we find our LCD, we can actually compare fractions using their LCD. We can also use a number line for this. Okay, but before we use a number line, let's talk about a multiple and denominators, what they're all about. So let me go to this page right here and let's talk about, let's say, if I want to find the multiple of 2. Okay, so when you talk about multiple is actually, okay, any number multiplied okay, any number multiplied by the number. So what does that mean? So if I want to find the multiple of 2, any number that I multiply with 2, which will be a multiple of 2. If I say 2 times 0, okay, 0 is a multiple of 2. 2 times 1, 2 is a multiple of 2. So the first multiple of any number will be 0. If I say 2 times 2, 4 is a multiple of 2. 2 times 3, 6 is a multiple of 2. And if I go further, 2 times 50, 100 is a multiple of 2. So those are all multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on and so forth. Okay? If I want to find the multiple of 5, for example, any number that I multiply with 5 will be a multiple of 5. So 5 times 0, okay, is 0. 5 times 1, that's the second multiple of 5. 5 times 2, move this here, a little bit up there. So 5 times 2, okay, is 10. 5 times 3 is 15. These are all multiples of 5. And if I do 5 times, let's say 50, okay, this is going to be 250. So 250 is still a multiple of 5, okay? So these are all what we call multiples. Now, what are common multiples? If I get the same two numbers, 2 and 5, and I want to find their multiples. So the multiples of 2 are 2, 0, 2, 4, 6, 8, 10, 12, 14, 16, and so on and so forth. Multiples of 5 are 0, 5, 10, 15, 20, and so on and so forth. Okay, do 18 and 20 here. There you go. Now, if you notice, okay, if we don't look at 0, we're not going to look at 0, okay? If we don't look at 0, what is the least common multiple of 2 and 5? We know that the least common multiple of 2 and 5 is 10. This is called your LCM, or the least common multiple. So if you also notice, okay, right here, 20 is a common multiple, but it's not the least common multiple. So when we talk about multiples, we want to find the least common multiple. So in this case, the least common multiple of 2 and 5 will be 10. Okay, let's take a look at how it's done with fractions. So with fractions, let's say I have 1/3 and I have 3/4. For me to be able to compare these two fractions, if I am going to compare these two fractions, okay, let's say I am going to compare these two fractions. I'm going to bring that up. I'm going to put a circle here. And I need to compare, I need to write a greater than, a less than, or an equal sign inside that circle. So for me to compare those two fractions using least common multiple, okay, remember what we talked about, least common multiple is the same as least common denominator. So when you talk about fractions now, you're looking for the least common denominator. So if you look at the multiples of 3 and 4, right here, because that's 3 and that's 4, okay? We look at their multiples. The multiples of 3 are 3. Okay, we're not going to write 0 anymore. It's going to be 3, 6, 9, 12, 15, 18, 21, 24, and so on and so forth. For 4, it's going to be 4, 8, 12, 16, 20, 24, and so on and so forth. So if you notice here, we have two multiples, common multiples, 24, and there are actually more multiples, but these are the only two that we'll look at right now. So we have 12 and 24. But you notice that the least common multiple will be 12. So this is our least common multiple. Remember, we talked about it's the same as LCD. So therefore, the least common denominator of 1/3 and 3/4 is 12 as well. So basically what we can do is we're going to get a 1/3, and we know that it has a common denominator of 12, and 3/4 as well has a common denominator of 12. Okay? So for us to compare those two fractions, we simply ask ourselves, what did I multiply 3 to get to 12? So I multiplied 3 by 4, and therefore I need to multiply 1 by 4. So whatever I do to the denominator, I need to do to the numerator for me to be able to make those two fractions equal. So 1 times 4 is 4, right there. What did I multiply 4 to get to 12? So I multiplied 4 by 3, and therefore I need to also multiply 3 by 3. Whatever you multiply with the denominator, okay, you need to multiply the numerator as well. 3 times 3 is 9. And all I do now is compare the numerators. So if you notice, 9 or 4, sorry, 4 is less than 9. So therefore, 4 twelfths is less than 9 over 12, or 1/3 is less than 3/4. That is how you use multiples or LCDs to be able to compare fractions. Okay? Okay, let's go back here then. So we know how that's done. Okay? And the example for least common multiple will be example number 2. We'll go back to example number 1 later. Okay? So in example number 2, we're asked to uh, fill in the circle with either a less than sign, a greater than sign, or an equal sign to make 7 over 12 and 8 over 18 a true sentence. So first we find the least common denominator of 12 and 18. Okay? And if we list 12 and 18 right here, and I look at the multiples of 12, this is 12, 24, 36, okay? And this is 18, 36. I can actually stop there because I already found, sorry, let me just redo this. This is 18, and this is 36. I can actually stop there because I already found the LCD or the LCM, which is the same as your LCD, okay? And that's how we got this 36 because of what we just did. Now, what did I multiply 12 with to get to 36? I multiplied it by 3. Therefore, I multiply 7 with 3, which gives me 21. What did I multiply 18 with to take me to 36? I multiplied it by 2. Therefore, I need to multiply 8 by 2 to get me to 16. And if you notice here, okay, 21 is greater than 16. So if 21 is greater than 16, 21 over 36 is greater than 16 over 36. Or if we go back to the original fractions, 7 over 12 is greater than 8 over 18. Okay? Now do the following problems, okay, on the questions that follow. All right, moving on. Take a look at example number 3. In Mr. Wong's class, 20% of students own roller shoes. In Mr. Trevino's class, okay, 5 out of 29 students own roller shoes. In which class does a greater fraction of students own roller shoes? Okay, so basically it's asking us to compare 20% and 5 out of 29. So it's easier for us to compare when they are both, okay, decimals. Okay, so we will express both of them as a decimal. We know that 20% is 0.02 because if you have a percent, all you need to do is move this decimal point 2 spaces to the left and you get your decimal. And that's why it's 0.2. In 5 over 29, we know that 5 divided by 29, if you do long division right here, will give you an approximate value of 0.1724. Okay, so in this case, okay, you can actually use a calculator and get that approximate value. And if you look at the two numbers, we know that 0.2 Okay, point 2 is greater than 0.7124 because you have 2 in the tens place and only 1 in the tens place for 0.174. And we know that 2 will always be greater than 1, and that's the reason why point 2 is greater than 0.1724. So converting that, we get 20% is greater than 5 over 29. Again, if this was too fast, stop the video, rewind it, watch it again. Okay, do that question. Okay, do the got it question. Okay, on the next question slide. So let's order rational numbers. We want to order the set 3.44 pi, 3.14, 3.44 pi, 3.14, and 3.4 bar notation from least to greatest. First, let's compare 3.4 or 3.14 and pi, these two right here. So we know that 3.14 is this this decimal. We annex a zero. Remember, when you have this fraction, when you have a decimal, it doesn't really matter how many zeros you add here. Okay, the decimal will remain the same. The only reason why we added 1 0, we annexed 1 0, annex means add, okay, is so that we can compare it with the decimal 3.1415926. So if you notice this decimal 3.14, okay, they have the same numbers. 3 is the same for both, 1 is the same for both, 4 is the same for both. And that's the reason why we have to annex a 0 so that we can compare some more. If we annex a 0 to 3.14, we know that 0 is less than 1. If 0 is less than 1, we know that 3.14 is less than pi, because this is now the approximate value of pi, 3.1415926. Okay? So we know that 3.14 is less than pi. Let's take a look at the last two numbers, 3.44 and 3.4. So you have 3.440 and 3.444. Now, why did we annex a 0? Okay, why did we add a 0? Because if you look at the numbers again, that's 3, same, same, they're equal. So the only time we can find the difference is that when we add a 0, this is a 0 and that's a 4. And we know that 0 is less than 4. Therefore, 3.44 is less than 3.4 bar notation on 4. Remember, in the last lesson, we know that 3.4 bar notation is the same as 3.4444, and the 4 repeats forever. Okay? So if we're going to arrange this from least to greatest, we know that the least number is 3.14. The next least number is pi, right here. The next least number is 3.4. And actually, the greatest number is 3.4 bar notation on 4. Okay, practice this skill. Do the got it at the bottom. The last example is basically the same as example number 4. So Nolan is a quarterback on the football team. He completed 67% of his passes in the first game. He completed 0.64, 3/5, 67%, and 69% of his passes. Okay? List Nolan's completed passing numbers from least to greatest. Now, if you notice, this is a decimal. This is also a this is a percent. This is a percent. This is a decimal, and this is a fraction. For us to be able to compare those four numbers, we need to convert all of them into decimals. So again, we convert 67% into a decimal. We know again how to be able to convert a percent into a decimal. We simply move the decimal place, which is here, 2 spaces to the left. And this one too, 2 spaces to the left. So that's the reason why when we have 0.67%, that's 0.67. Okay, 0.64 is already given, so we don't touch it. 3/5, again, for us to be able to get 3/5, we did 3 divided by 5. Decimal there, bring it up, add a 0. 5 there, 6, 5s and 30, subtract 0. And that's how you get 0.6. 69%, again, moving 2 spaces to the left, will give you 0.69. So now we apply the skill that we learned in the last example, okay? And if we line them all up, I have 67%. I'll write down all the decimals, 0.67, 0.64, 0.6, and 0.69. Okay, these are the decimals written down here. I just wrote them down. So let's compare using the hundredths place value. If we're comparing hundredths place value, we need to annex a 0 to 0.6. So if you notice, 0 is the least, okay? So this is the least number. We'll put that as number 1. The next least number is 4, so we'll put that as number 2. The next least number is 7, number 3, and the greatest number is 9. Remember, we are simply comparing, okay, the hundredths place value. Okay, so if we do that, we end up with 3/5, which is the least number, which is 0.6. Okay, 0.64 is next because that's number 2, right there, number 2. Okay, 67% is 0.67, and 69% is 0.69. Okay, and that's our lesson. Thank you for watching.